Today we're going to prove statements about segment and angle relationships. Okay, we're going to learn different properties of congruence, which you actually kind of know, except we're just putting them in a different situation. Okay. We're going to look at a couple new theorems. Again, you need to know these theorems, and I've given you a graphic organizer today in class that you can use however you want, but you need to know those theorems. So our properties of congruence are going to be reflexive, symmetric, and transitive, and they're basically the same as when we looked at them with equality. So the reflexive property of congruence is basically something is congruent to itself. Now again, it kind of seems silly. However, we're going to use that a lot in the next chapter when we're proving things are congruent, like shapes. Okay, and the symmetric is still, if angle R is congruent to angle T, then angle T is congruent to angle R. When you think about that algebraically, remember it's when people don't like the variable on the right side of the equation, so a lot of people flip them to the left. Okay, and that's just the symmetric property. And then the transitive property of congruence is taking out the middleman. It's like law of syllogism that we studied in the last unit, where if I break my screen, my parents will be angry. If my parents will be angry, they will ground me. Then if I break my screen, my parents will guard me. So it's that same concept, right? So with congruence and congruent figures, if segment TE is congruent to segment MS and segment MS is congruent to segment AB, then segment TE is congruent to segment AB. So we've taken out the middleman and squished it together. Okay, so a little nuance, or thing that's kind of a sticking point with math. If I'm talking about congruence with geometric figures. So when I'm proving something, I use properties of congruence with geometric figures. If I'm stating that two things are congruent or two triangles are congruent to each other, then I use property of congruence. If I'm talking about their measurements, then I'm talking about properties of equality. And you've got to pay attention to that when doing proofs. So this next theorem is pretty common sense. It's the right angle congruence theorem, and it states all right angles are congruent. When doing proofs, I don't care if you say right angle congruence theorem or all right angles are congruent. It's kind of shorter, I think, to say all right angles are congruent. But that's your choice. So if it makes sense, right? So if a right angle by definition is 90 degrees, then if I've got two right angles, they both measure 90 degrees, so they're congruent to each other by definition of congruence. Now we have the congruent complements theorem and the congruent supplements theorem. They're basically the same thing, but one deals with complementary angles and the other deals with supplementary angles. And they say that if two angles are complementary to the same angle or congruent angles, then they are congruent. Okay, and then the congruent supplements is the same thing, but with supplementary angles. So if I have, what does that mean? These three angles, and I know that angle 1 and angle 2 are supplementary. Okay. And I know that angle 2 and angle 3 are supplementary. Then according to this theorem, I apologize for that, according to this theorem, okay, angle 1 and angle 3 are also supplementary. And we're actually going to prove that later in this lesson. Okay, We also have the linear pair postulate that says if two angles form a linear pair, then they're supplementary. So basically, I know that I have a linear pair. 1 and 2 are a linear pair. They lie on a line, okay, and they share a common side and a common vertex. Then they're supplementary, so they add to 180. And we've talked about that in the last couple lessons. But now we're actually giving it a theorem or a postulate. Then we have the vertical angle congruence, and we talked about this too, that says vertical angles are congruent. Now again, if I have to use these in a proof, it's probably easier to write linear pair postulate, but it might be easier to write vertical angles are congruent for the vertical angles congruence theorem. It's up to you, whichever works best for you. I'm not going to be real picky about that as long as you either write out what the theorem or postulate says or if you tell me the title. So now what we're going to do is we're going to prove that congruent supplement theorem. Okay. So we usually start with our givens, and sometimes we can split them up when it makes sense. But in this case, we're going to use the fact that these are supplementary, okay, and we're going to follow in the logical step. So last week or the week before, we did proving, we played with Uno basically, right? We said that if I want to get from a yellow 2 to a red 4, you know, and we had certain cards, we might have to play the red 2 and then we can play the red 4. Okay, so we're going to follow that same logic here. So angle 1 and angle 2 are supplementary, as is angle 2 and angle 3. And so my given is up here. So in this case, it doesn't make sense to split them. So I'm going to write given. Notice this is 2 columns. The statements are always on the left and the reasons are the right. I'm using a table to keep it organized. If you don't use a table, you need to match up numbers. You would have to say that this is a reason 1 and this is a reason, that's statement 1, the first one, and then this is reason 1. So what follows after that is there's not much more we can do with supplementary, but we know that 2 angles are supplementary, they add to 180. So that's the next logical step to get where I want to go. And that is by definition of supplementary angles. So definition of supplementary angles. This tells us that if 2 angles are supplementary, then they are, their measure is 180. Now my next thing that you want to notice is that I've got 180 and 180 the same here. So what I've done is I know that the measure of angle 2 plus the measure of angle 3 is 180, so I can put it here. Okay. And again, I apologize. We're going to use the transitive property of equality to say that that works because we've taken out the middleman and we've squished it together. Now, you may also use substitution of equality. So we did substitution with, you use substitution with systems last year. If they were both equal to y, you put them equal to each other. Same idea here. Now notice from the step here to the next step, I've got measure of angle 1 there, I've got the measure of angle 3 here, but I've gotten rid of the measure of angle 2. Now I didn't get rid of it. What I did was I subtracted it from both sides. It's the same quantity, so I'm subtracting it from both sides. So that is the subtraction property of equality. And now what I'm trying to prove is that these are congruent, and I've got the measure of angle 1 equal to the measure of angle 3, which means that those are congruent by the definition of congruence. So I want you to understand that I followed logically step by step what makes sense. And then I went on to prove that. Now, back in the day when your parents took geometry and when I took geometry, we had to prove every theorem, or most, before we used them. We're not going to prove every theorem, okay? But sometimes when I ask you to prove a theorem, we're looking at all the middle steps to get us to the end. Now we're going to prove that some segments are congruent. So AB, the measure of AB is equal to the measure of DE, and the measure of BC is equal to the measure of CD. And notice that I've marked them congruent on the diagram. So I'm going to not split my givens this time. And what I want you to notice is that I've taken the statement AB plus DE and I've added BC to both sides. So that is the addition property of equality. Now what I've done, if I go from the second statement to the third statement, is it's almost the same. I've got the AB and AB, I've got the BC and the BC, and the DE and the DE, but here this is different. But what I've done, because these are equal, is I've substituted CD in for BC. So that's substitution property of equality. Next, I've used the segment addition postulate. How do I know that? I've got AB plus BC equal to AC. So I've got AB plus BC equal to the whole segment. And then it's the same thing with CD and DE equal to that whole segment. Okay. So that is your segment addition postulate, which we learned earlier. Notice that here I've got the B in between and then the A and the C on the outside equal to the AC, and same here. So that's how I can notice the segment addition postulate. From there, I'm saying that I'm going from CD plus DE equal to AC. So it looks like I've subbed in, but I haven't, because those aren't equal yet. We haven't been able to say that those are equal. What we do know is that AB plus BC equals CD. So I've taken the CD plus the DE right here, and I've substituted it in for the AB plus BC. Okay? And that's where I get this statement, CD plus DE equals AC. So I've done a direct substitution from here to here. And it looks like I skipped the reasons, got them mixed up. So substitution property of equality there. Now from this statement here to this statement here, I've gone from CD plus DE equals AC to now saying that AC is equal to CE, and I've used the transitive property, okay? Because I know that CD plus DE equals CE and CD plus DE equals AC. So I've knocked out this middleman to say that those are equal. Now, because those measurements are equal, AC, the measure of AC is equal to the measure of CE, I can say that those segments are now congruent. That segment AC is congruent to segment CE by the definition of congruence. Right. Here are some proof tips. So label diagrams with what you know If you can label angles, and this will get into more with numbers, instead of having to look at all 3 letters to name an angle, we can also name them with numbers. When stating what something is, we use definitions and follow each step with what logically follows it, back to the UNO. Now these are just 2 examples that I'm going to teach this again in class tomorrow with some different examples, but I just want this video to be there for you guys to refer back to when you get stuck. So you're going to see it at home and you're going to see it in class again, because proof can be a tricky thing. So you've learned all of these theorems today, and you've learned how to do a proof. Again, we're going to spend more time on this in class, spend a couple days, because if we get proofs down early, we're going to get it for the rest of the year. So have a mathtastic day.